Okay, now continuing with exponential equations. So like the log equations, really there's two situations you want to be aware of. So I want to either try to achieve like bases equal to one another. So something like, and we've talked about this already, a to the u equals a to the v would imply u is equal to v. So if I can get one expression equal to the other where we have like bases, then we can set the exponents equal to one another. So that's one thing I can do, but sometimes you can't do that. So when you can't do that, we're going to look at a method where you can apply natural log to both sides of the equation. And that allows you to use properties of logs to then simplify and solve. Alright, so let's look at a couple of examples. If we continue on the study guide, I know I skipped around a little bit, but if you look at number 4 on page 216, we have 5 to the 1 minus 2x is equal to 1/5. So this is a situation where I can achieve like bases, because 1/5 is the same as 5 to the negative 1. So that means I can just set the exponents equal to one another and then solve. So I would have negative 2x is equal to negative 1 minus 1, or negative 2, and then divide both sides by negative 2, and x is equal to 1. Remember, with exponential functions, the domain is all real numbers, so although it's not a bad idea to check, we're not as concerned with a restricted domain. Okay. The next one on the study guide works similarly. That's number 5, where we have 4 to the x squared. That's very little, it's hard to see. And 2 to the x, so equals 2 to the x. So again, I can achieve like bases because I can rewrite 4 as 2 squared. So if I replace the 4 with 2 squared to the x squared is equal to 2 to the x. Remember, in this situation, I multiply. Then I can set 2x squared equal to x. I'm solving a quadratic. So subtract x to set that equal to 0, factor, and set each factor to 0. So x equals 0, 2x minus 1 equals 0, and then this will give me 2x equals 1, and x equals 1/2. Alright, let's look at an example or two where you don't have, or you can't manipulate like bases. For example, the next one, number 6, we have 3 to the x is equal to 14. Now there's no way I can rewrite 14 with a base of 3. So in this case, we're going to apply natural log to both sides. So let's take a look at that. So by that I mean I'm going to look at the natural log of 3 to the x equals the natural log of 14. So remember, natural log of 14 is a number. I can plug that into my calculator and get an estimate, but it's a number, it's a decimal. So again, the object is to get x by itself. So remember your properties of logarithms. I can bring this down, so this is x natural log of 3 is equal to the natural log of 14. Now in an effort to get x by itself, I'll divide both sides by natural log of 3. So x is equal to natural log 14 over natural log of 3. Now, when you go to the MyLabs Plus, it will ask you for an exact solution, and this is what it wants. So you want to type this in natural log form because that's an exact number. If I get a decimal for this and divide it by an estimate for this, I don't get an exact value. So in the MyLabs Plus, this is what you want your answer to look like. You just type the ln off your keyboard, 14 divided by ln of 3. But that's what you need to enter. Okay, let's look at another example. This one you can just jot down, and the other examples are on the back. Again, this one I think is a little bit more complicated than the ones listed on your sheet, and you will see one like this on the MyLabs Plus. So let's look at, oh, I just copied down the wrong one. Alright, so 9 over 2 to the x is equal to 6 to the 1 minus x. So again, I can't manipulate like bases, so I'm going to apply natural log to both sides. So I have natural log of 9 over 2 to the x is equal to natural log of 6 to the 1 minus x. So what this enables me to do is to pull down those exponents. So this becomes x times the natural log of 9 over 2 is equal to, remember that is an expression in itself, so keep it together, 1 minus x times the natural log of 6. Those parentheses are important because now I'm going to have to distribute this number. So again, let's go ahead and get rid of those parentheses. X natural log of 9 over 2 is equal to, distributing the natural log of 6, this will be the natural log of 6 times 1, or just natural log of 6, minus x times the natural log of 6. Okay, so now, remember, my object is to get x by itself. So, I want to get anything that has an x on one side and everything that doesn't have an x on the other. So let's add this term to both sides. So, on the left, I'll have x natural log of 9 over 2 plus natural log, or that's x natural log of 6, is equal to the natural log of 6. Now, since I have my x terms on the left, I can factor an x out. So I'm left with natural log of 9 over 2 plus natural log of 6 is equal to natural log of 6. Let me get myself a little bit more room. So now to get x by itself, I'm going to divide both sides by everything but the x. So this cancels, and I'm left with x equals the natural log of 6 over natural log of 9 over 2 plus natural log of 6. Now again, in the MyLabs Plus, this is the exact value that you're expected to enter. Although with this problem, you're also asked then for a decimal estimate. So be careful when you plug this into your calculator. Make sure your numerator is in parentheses and your denominator is in parentheses. Otherwise, it might do something kind of funky. When you do enter this in, and I did this somewhere, but I don't think I wrote it down, but I can do it real quick. So when you enter this into your calculator, let's see, so be careful, parentheses around the numerator and parentheses around the denominator. So this is okay. So we get 0.5436. However, I think in the MyLabs Plus it'll ask you to round to 3 places. So it would be 0.544. Okay, so we're going to stop it here. Please take a look at the MyLabs Plus assignment so we can wrap this up and prepare for the test.